Yes, good morning students. In previous classes we discussed about transpose of matrix as well two properties of transpose of matrix, that is A dash whole dash equals to A plus B whole dash equals to A dash plus B dash. These two properties are done. Now today we will discuss two more properties of transpose of matrices as well as some more applications on transpose of matrix, that is symmetric matrix, skew symmetric matrix, and writing a given matrix as a sum of symmetric and skew symmetric matrix of itself. Some more properties arise, some more applications on transpose of matrix you people will learn about. Before that, first let me learn the third property of transpose of matrix. Transpose of a matrix. As we discussed in previous class, transpose of matrix nothing but interchanging rows and columns. Transpose of a matrix nothing but interchanging of rows into columns, arrays, columns into rows, any one, not both at a time. Now let me discuss third property. So as we discussed two properties you learn, one is A dash whole dash, I mean transpose of a given matrix equals to given matrix. The next one is A plus B whole transpose equals to A transpose plus B transpose. Let us discuss third property as K some. Let me take K is one constant. KB whole transpose equals to K into B transpose. K is a scalar quantity. R one scalar quantity. R is constant element. So we consider one matrix B as we consider 2 minus 1 2, another 1 2 4. This is of order 2 rows 3 columns. Let us K is any constant, that is up to you. 2B whole transpose, that we find 2 of what is B matrix, students? 2 minus 1 2. Then after 1 2 4 whole transpose. When we multiply, let me take 3 without getting any confused. Now 3B means when we multiply a constant or a scalar quantity, we should multiply each and every element of given matrix, that is 3 to the 6 plus into minus minus 3, 3 to the 6, 3 1 the 3, 3 to the 6, 3 4 the 12 whole transpose. I mean we got a 3B matrix like this. Don't write transpose here. Now let us find 3B whole transpose. What is 3B value? So we have transpose means changing rows into columns or columns into rows. That is up to you, which operation you want you can apply. Now we got the result. This row become column. 6 minus 3 become 6 minus 3 6. One column. I mean first row become column. This row become column. So order of this matrix is 3 by 2, as we know 3 rows. As we discussed already, if order of a matrix is m by n, then order of its adjacent matrix is n by m. So means it get reverse. Let me check whether it is true or not. We have this one, 3 into B transpose, that is 3 into, what is transpose of B? B is given, so change rows into columns, arrays, columns into rows. That is up to you, students. There is no rule to follow this method only. You can change it. Anyhow, same answer you will get, of course. Then again multiply 6, 3 1 the 3, 3 to the 6, 3 1 the 3, minus 3, 3 to the 6, 3 to the 6, 12. So we have, this is 3 by 2, which is equals to 3B transpose. Therefore, we can conclude that 3B transpose equals to 3 into B transpose. Universally it is applicable. Once again I am repeating, students. Let us consider one matrix B. K, one scalar quantity 3. 3 are any constant or variable, that is up to you. Scalar quantity that should be. Then we follow the method. We know transpose means changing rows into columns, columns into rows. So we have the result as 3B whole transpose equal to 3 into B transpose. This is third property. Now we have fourth property. Let us so in previous example, we discussed about how K B whole dash equals to K into B dash. I mean, when we multiply by a scalar quantity, how the transpose of matrix it changes, the property we discuss. Let us discuss about AB whole dash equals to B dash A dash. Let me take first AB whole dash will find, then after we'll check with this one. Let us find. Now AB. AB means multiply A matrix by B matrix. We know by the properties of multiplication of matrix, number of columns of first matrix must be equal to number of rows of second matrix. Yes, equal. And the order of resultant matrix is rows of first matrix by columns of second matrix. Yes, we know well. Already we discussed many times. Now let us row into column, first row into first column, second row into, like that we have to do. So now minus 2 into 1 minus 2. This is first row, first column, first row, second column, first row, third column. Minus 2 into minus 1, minus 2 into 1, minus 2, minus 2 into 3. So we have to do like this. Now minus 2 into 1, minus 2, minus 2 into 3, minus 6, minus 2 into minus, plus 2 6 are 12. Again, now first row with first column, second column, third column over. Now second row with first column, 4 1s are 4, 4 3s are 12, plus into minus, 4 6 are 24. Second row into first column, second row into second column, second row into third column. This first row of product matrix will get. Now 5 1s are 5, 5 3s are. Now we get 5 3s are 15. Students, now to prove AB transpose of AB product equals to B transpose into A transpose. Let us we consider A matrix as minus 2 4 5, which is the order of 3 by 1. B matrix as 1 3 minus 6, which is order of 1 by 3. Then after let us we find AB, because first we will find the transpose of AB. Then after we will find B transpose into transpose of A. We will prove these two are equal. Let us we find AB. A matrix is minus 2 4 5 into B matrix is 1 3 minus 6. We know row into column. Here these are rows, these are columns. So let us we check product is possible or not. Yes, possible, because column is one column. Here column of first row, number of columns in first matrix is 1, number of rows in second matrix is 1. So order will be 3 by 3. Let us minus 2 into 1 minus 2. You know, because another element is not there in this column. So one time only. Minus 2 into 3 minus 6. First row into first column, first row into second column, first row into third column. We get the element same, because we have one element in rows, one element in columns. That is why it is happening like that. Don't get any confuse here. So minus 2 into 1 minus 2, minus 2 into 3 minus 6, minus 2 into minus 6 plus 12. Again 4 1s are 4, 4 3s are 12, 4 into minus 6 minus 24, 5 1s are 5, 5 3s are 15, 5 into minus 6 minus 30. Again AB whole transpose. I mean transpose of AB matrix. AB we have here, write its transpose, that is minus 2 4 5. Column become row, or else row become column, that is up to you. Row is minus 2 minus 6 12 become column. Row, second row becomes second column. third row become third column. So we have AB transpose. Let us we find the value of B transpose into A transpose. Let us check whether it is true or not. Now let us we check. Previously we found, previous steps we found AB transpose value as minus 2, 4, 5, minus 6, 12, 15, 12, minus 24, minus 30, which is order of 3 by 3. Now let us, we have to check that is equals to B transpose into A transpose. Find B transpose, which is B matrix is 1 by 3. So order of B transpose will be 3 by 1. Then after A transpose, matrix A order is 3 by 1. When you take, you will get A transpose as 1 by 3. So now let us we find the value of B transpose into A transpose. Let us we check whether it is possible or not. Yes, columns of first matrix equals to rows of second matrix, so possible. Order of matrix is 3 by 3, which is defined as rows of first column by columns of second column in the product. So B transpose into A transpose, same manner. 1 into minus 2, minus 2. 3, 1 into 4, 4. 1 into 5, 5. First row into first column, first row into second column, first row into third column. We have done. Again 3 into minus 2, minus 6. 3 into 4, 12. 3 into 5, 15. Second row into first column, second row into second column, second row into third column. We have minus 6 into minus 2 minus plus 12, minus into minus plus 12, minus into plus minus 24, minus into plus minus 30. We have 3 by 3. Already we have AB transpose. This matrix we got previous steps. Now we have B transpose into A transpose, this one. So these two are equal for any two matrix when it is possible, when the product is applicable. This property of transpose of matrices are applicable for any matrices where multiplication is possible by the properties. So hence verified. Till now we discussed first property for transpose of matrix and 4 properties of transpose of matrices we discussed till now. So let us we go through some more applications on transpose. I mean symmetric matrix, skew symmetric matrix. These all definitions and applications on transpose of matrix we will do. You will get home assignment whatever we will discuss in this class. So we'll continue further next class. Within 2 more classes total matrices chapter will finish. So please go through textbook. E-textbook is available. Do your classwork, revise well. All the concepts do well as a part of portfolio if you complete better, because it is easy to revise for you before examinations. And go to take a R.D. Sharma reference book, e-book if possible, or else NCERT exemplar book is available in net. You can download it and you can go through NCERT exemplar problems also. If you have any doubt of coming back to class, you can clarify. Thank you. Now let us we discuss about symmetric matrix. What is symmetric matrix? Symmetric matrix is exist only for square matrix. If it is square matrix, a square matrix A is defined as Aij. I mean every element is in the form of Aij. We know square matrix means M by M. You know well. You can write like this also, of course. M by M. M by M. Square matrix means you know well. So Aij M by M order matrix is said to be symmetric if A equals to A dash. A transpose means a given matrix equals to transpose of itself. Transpose to itself. Then it is called as symmetric matrix. Once again I am repeating, students. You know what is transpose of matrix. So if any square matrix is possible to write transpose of matrix to itself, then it is called as symmetric matrix. Let us we consider one matrix which is 3 by 3 order. let us be define as root 3 to 3. 3 rows, 3 columns. First row is root 3 to 3. Second row is 2 minus 15 minus 1. Third row is 3 minus 1, 1. If you write its transpose, I mean change rows into columns, that's it. Don't change both at a time. Again, you will get another type. So, rows into columns or else columns into rows. That is up to you. Root 3 into 2, 3, it becomes first row. First row becomes first column. Second row becomes second column. Third row becomes third column. If you observe, see students, same matrix we got. So, this type of matrices are called symmetric matrix. Symmetric matrix means if transpose of a given matrix is equal to itself, then it is called symmetric matrix. I mean, and the symmetric matrices exist only for square matrix. So let us continue with skew symmetric matrix and some more properties on transpose of matrix, students. So now previously we discussed about symmetric matrix, students. Now let us discuss about skew symmetric matrix. It is also, even skew symmetric matrix also exists for only square matrix. A square matrix B. B means let us consider B. It may be A, X, whatever may be a matrix. A square matrix B is said to be skew symmetric matrix if B dash equals to minus B. The difference between symmetric and skew symmetric is, in symmetric matrix, transpose it to itself, transpose of matrix equals to itself. But here, transpose of matrix equals to additive inverse to itself. Additive inverse to itself. RF negative matrix to itself. So if B dash equals to minus B, that is minus of Aij m by n m by m equals to Aj I mean interchanging the rows and columns, then we get. This is the procedure to follow. This is transpose of given matrix. This is minus of Aj m by m. I mean I wrote like that. Okay students, or else if you get doubt you can write like this also, no issue. So minus to itself. Transpose of a matrix equals to negative matrix to itself, or else additive inverse to itself. Let us consider one example. And one more point, students. In a skew symmetric matrix, let me write later. Now let us take B matrix as 0 E F minus E 0 G minus F minus G 0, which is 3 by 3 matrix. Scalar quantities means we can take any variable also. If you take its transpose, let us change rows as columns, columns as rows. Then we get 0 E F minus E minus E 0 G minus F minus G 0. If you factorize minus 1 from this, minus become plus, students. That is 0, no change. Minus E become plus E, minus F become plus F, plus E become minus E 0 plus G. Here plus F become minus F minus G 0. This is already we know B, minus 1 into B, that is minus B. So transpose of a matrix equals to negative to or additive inverse to itself, then that is called skew symmetric matrix. You observe, students, diagonal element of a skew symmetric matrix always zeros. Diagonal elements of a skew symmetric matrix. A skew symmetric matrix are always zeros, are 0. You observe? So you can frame, you can take more examples to check the skew symmetric matrix, but the only thing is transpose of a matrix equals to negative to itself or else additive inverse to itself, then that is called skew symmetric matrix. Till today, till this point, you learn about some properties of transpose of matrix. Next, symmetric matrix. Next, skew symmetric matrix. Let us discuss about some more applications on transpose of matrix, students. Now, some more applications on transpose of matrix. Let us take for any square matrix A. You take any square matrix, students. You can frame as you wish. For any square matrix A with real number entries, I mean elements are real numbers. A plus A dash, I mean sum of its matrix and its transpose. Sum of the given matrix and its transpose is always symmetric matrix. So let us, another property or application on transpose of matrix is for any square matrix A with real number entries or with real numbers as elements, A plus A transpose, I mean sum of a matrix and transpose to itself is symmetric. Let us take one example. Let us you consider any square matrix. I have considered 2 by 2. You can take 3 by 3, 4 by 4 as you wish. 1 minus 2 minus 3, 4. Its transpose what, students? You know transpose means changing rows as columns. Okay, or columns as rows, that is up to you. 1 minus 3 minus 2, 4. It is also 2 by 2. Generally, we will get like that. Very transpose is exist in any matrix, but this property is only for square matrix. Skew matrix, symmetric matrix, skew symmetric matrix exist only for square matrix. I mean, we can define a matrix as symmetric matrix or skew symmetric matrix when it is square matrix. So we can define a matrix or given matrix as symmetric matrix or skew symmetric matrix when it is square matrix, but transpose of matrix exists for any matrix. But here also this application is applicable when it is square matrix only, or else not possible. That is why let us consider one square matrix. Its transpose we got. Find sum of let us take the sum of a transpose sum of given matrix and its transpose as P. I am considering, let us consider if when we add, addition is possible when their order of matrix are equal. Property for subtraction and multiplication also. Yes, 1 plus 1, 2, minus 2 plus minus 3. Both are negative quantities. We should add and take minus symbol. Minus 5, minus 3 plus minus 2, minus 5, 4 plus 4, 8. You know how to find addition of two matrices. Let us consider P. Its transpose. Transpose of P. That is nothing but transpose of P. Nothing but A plus A transpose whole transpose. Then P transpose we got as minus 2 minus 5 minus 5 minus 8 when we change columns into rows or else rows into columns. That is up to you. Whenever we change also same, both are same. I mean transpose of given matrix equals to given matrix. So A plus A dash is a symmetric matrix. For any square matrix A, it is proved. Let us discuss one more application on transpose of matrix. So students, understood students? Once again I am repeating. So let us take one square matrix and then we find its transpose. Find sum of given matrix and its transpose. Let us consider as P, that sum, and then after find the transpose of its sum, nothing but P transpose, both are equal. So it is symmetric matrix. P is what, students, here? A plus A transpose. A is given matrix, A transpose is transpose of given matrix. So we have, so it is proved that sum of a matrix and its transpose always symmetric matrix. Let us discuss one more property or application of transpose matrix. Application on transpose of matrix. Now we'll discuss about fourth application or property on transpose. For any square matrix B or A up to you, with real numbers as entries or real numbers as elements, B minus B dash, I mean subtraction, difference between given matrix and transpose to itself. I mean first given matrix minus transpose of itself. Then it is a skew symmetric matrix. For any square matrix is applicable, students. Let us consider B matrix as, which is order 3 by 3, 1, 5, 6 first row, minus 3, 2, 4 second row, 9, 0, minus 7 third row. Then we will find its transpose. Then B transpose to B or B dash equals to 1 minus 3, 9, 5 to 0, 6, 4 minus 7. We have its transpose. So let us find the difference between B and transpose of B. We have 1, 5, 6, minus 3, 2, 4, 9, 0, minus 7, minus 1, minus 3, 9. I mean transpose. Changing rows into columns. Minus 3, I mean 1, minus 3, 9, 5 to 0, 6, 4, minus 7. Difference is 1 minus 1, 0. 5 minus into minus plus 8, 3, 8. That is, I mean 5 minus into minus plus 5 plus 3, 8. 6 minus 9, larger number negative, minus 3. Then minus 3 minus 5, minus 8. 2 minus 2, 0. 4 minus 0, 4. 9 minus 6, 3. 0 minus 4, minus 4. Minus 7, minus into minus. Here it is minus, students. Minus into minus plus. Minus 7 plus 7, 0. So let us, if you consider it is as Q, we have Q, it's a its transpose is, let us change rows as columns. 0, 8 minus 3 become first column, first row, second row becomes second column, third row becomes third column. If you observe, students, each and every element is its head to inverse, so we can write minus 1 into this one, that is nothing but minus Q. Q, transpose of Q equals to minus Q. Therefore, we can say that B minus B dash is a skew symmetric matrix. So this is one of the applications, students. Let us. So for any square matrix, if you take the difference between itself and transpose to itself, the total matrix becomes a skew symmetric matrix. That is, we consider one square matrix and it's a transpose. We have the difference between given matrix and transpose. Let me consider one matrix as Q. Again, it will be square matrix, as you know. Difference are some possible when order of matrices are same. So we have 1 minus 1, 0. We follow the method. Then we have Q dash, that is nothing but transpose of Q equals to minus Q, as we proved. So B minus B transpose is always a skew matrix when B matrix is a square matrix. Now till this point we discussed about transpose of matrix, properties on transpose of matrix, symmetric matrix, skew symmetric matrix, how to define symmetric matrix and skew symmetric matrix, as summoned difference of its given square matrix and its transpose. Nothing but applications on transpose of matrix. Now you will get some home assignment on this model, students. Do it as homework in your classwork notebook backside. Stick that home assignment. And if you have any single doubt from starting point or concept of matrices till this, you can clarify your doubts after coming back to class. Now you will discuss about some elementary operations on transpose and its applications next class. And within 2 classes, the total chapter will complete. The rest models we will finish next class as well as next 2 classes. But don't forget to go through with the e-textbook and solve the remaining problems and get one NCERT exemplar textbook, e-textbook you can download from website, then go through that, practice all those problems. This chapter is very easy to understand. The only problem, regular revision is required. Though you have doubt, you can ask me after coming back to the class. Yes, students. Thank you. So revise all the topics, students, and you can ask me, you can get clarification after coming back to the school. But don't forget to revise daily basis. Very easy to understand each and every concept of this topic. Thank you.